Hi, my name is Sarah Stevens.
Okay, so today we're going to be using the percent composition of equilin, which is a hormone isolated from horses, and we're going to be using the percent composition to find both the empirical and molecular formula. So first you want to start by finding the atomic mass of each element, and we're going to do this by using the periodic table. So we have 80.56% carbon, 7.51% hydrogen, and 11.92% oxygen. So first we want to start out by writing out our atomic mass of each element we're going to be using. So I looked at the periodic table, and carbon is 12.011 grams, and then hydrogen is 1.008 grams, and then oxygen is 15.999 grams. So that's where we're going to start. So then for part A, we're going to be using this to find the empirical formula before we find the molecular formula. So part A is finding the empirical formula. So we're going to begin by taking our composition and thinking of them as grams rather than percents. So we're going to write over here carbon, and we're going to just put over here like that carbon and our hydrogen and our oxygen, and we're going to want to write this as grams instead of our percent. So 80.56 grams carbon, 7.51 grams of hydrogen, and 11.92 grams of oxygen. So from there, we're going to divide these by their atomic mass. So we're going to be putting these on the bottom. So we're going to want to do that. And then since it's carbon, we put our 12.0. All right, just like that. And then we're going to do it for the rest of them, taking it from there. Ooh. Let me make sure I put the right numbers. Okay, so these numbers will then be divided by these. And this is going to be converting our grams into moles, which is what we want for the next step. So once we do that, we do the dividing. I put it into a calculator so that I'm not going to write all out by hand because I'm sure no one wants to watch that. You get an eraser. But I ended up with 6.707 moles of carbon, 7.452 moles of hydrogen, and then 0.745 moles of oxygen. So after dividing, it's clear that these numbers aren't integers that we want to use for our empirical formula. So what we're going to do is to turn these into integers. We are going to divide each of them by the smallest amount. So our smallest amount clearly is this one. So we're just going to divide each of them by 0.745, like that, which we know this one will equal to 1. I put this into my calculator as well, and this equals 9.003. And this one for hydrogen equals 10.003. So these two are close enough to just round to 9 and 10. This one's 1, so that one's good. So our empirical formula for equilin is going to be, let's see, C9, because we get our 9 from there, H10, because we're getting our 10 from there, and then O, we don't have to put the 1 because it's just 1. And that is our empirical formula. So next, I'm going to erase this with my hand because I do not have an eraser for some reason. And I'm going to be finding the molecular formula using what we have found. So now we're going to move on to part B, which is finding the molecular formula. And so what the problem tells us as well is that our molar mass of equilin is 268 grams. Okay, so there we have that. So we are going to start by multiplying the integers of our empirical formula by the element atomic mass. So we're going to do that by 9. We're getting the 9 from here, and then the 12 is our atomic mass of carbon, 12.11. Okay, then plus hydrogen, the 10, we're bringing the 10 up here, times what's hydrogen's atomic mass is 1.0078, plus, we know there's only one of those, which we don't have to write that, and we know the atomic mass of oxygen is 15.999. So then, from there, all of that equals 134.176, which clearly does not equal 268. So we know that is not it. So then my next step would be to take 268 and divide it by 134.176, just to see how many times it's going to go into it, which this goes into it twice. So we know that this is going to have to be multiplied, all of these are going to have to be multiplied by 2 in order for the molar mass to be this. So what we're going to want to do is multiply each of these numbers by 2. So we'll have carbon will be 18, because 9 times 2 is 18. Hydrogen will be 20, and oxygen is going to be 2. And this is molecular formula of equilin. which, excuse my handwriting, I was at a weird angle, but this is our molecular formula. We're going to be calculating the percent composition of lactose. So lactose is most commonly found in milk, and its medicinal, I can't say that word very well, medicinal name is also lactose. I'm sorry, I'm terrible at pronouncing that. But we're going to start with the chemical formula for lactose, which is C12H22 and O11. So from there, we are going to write the atomic mass and of each of our elements. So C, we know from the last problem, grams. H is as good as these are the same as the last problem, so we already have these amounts. So from here, we want to calculate what the molecular mass is for the formula altogether, because we're going to need that in our calculations for later. So we're going to take our 12, and we're going to put 12 here, times this, which are, right here, our atomic mass, 12.011 grams. All right, then plus our, taking 22 from here, 22 times 1.0078 grams, plus our 11 times 15.999 grams, which we end up, when I put it in the calculator, we end up getting a molar mass of 342.293 grams of lactose. Okay, so we're going to use this in our next steps. So I'm going to erase this part because we got our calculations from that. We don't really need that right now. Okay, so now what we're going to do is we are going to use this, this, and this to calculate our percent composition. So to calculate the percent composition, so to calculate the percent mass of each element, we're going to use on top the number of atoms each element has in the molecule times the atomic mass of the element over the molecular or formula mass of the compound, which is what we just found. And then do that whole thing times 100. So starting with carbon, we are going to do our percent of carbon equals 12, we're getting 12 from there, times 12.011 grams, which we're getting from here, all over the number we just found right here. And that, when I put, oh, can't forget the times 100, 100%. And when I plug that into the calculator, I got 42.108%. Now for the next one, percent hydrogen equals, we're going to do the same process. All right, we're going to take our 22 times 1.0078 all over 342.293 grams times 100%, and that is going to equal 6.477%. And then we're going to do our percent oxygen, which is our 11 from there, this from there, all over 42.293 grams times 100%. I keep almost forgetting that, equals the 51.415%. Okay, so from there, I want to make sure that I keep, I'm going to get rid of the things we did, but make sure that I keep my percentages I just got for each thing. And I want to add them up and make sure that I get 100. So when I put them in my calculator, I did end up with 100%, which is exactly what we want, so I can check that off that I checked it. And what we're going to end up with is we're going to have 42.108% carbon. We're going to have 6.477% hydrogen and 51.415% oxygen to make up our lactose, our percent composition for lactose.